Hello students, welcome back to my channel. Today we will study the topics of jam differential equation, that is, we will learn about linear combination of functions, linearly independent functions over an interval, linearly dependent functions and some of its properties. We will learn about general form of linear differential equation of n order as well as of second order, uniqueness and existence theorem, key statement. Now, let's get started.
What do you mean by linear combination? Given fi the functions defined on an interval I and ci are arbitrary constants, then the function summation ci fi, that is c1 f1 plus and so on up to cn fn, where I varies from 1 to n, is called the linear combination of fi over I. Example, if we take the functions a minus x e raised to power x and e raised to power 2x such that their arbitrary constants are 1, 2 and minus 4, then linear combination would be e minus x plus 2 e raised to power x minus 4 e raised to power 2x. Now, what do you mean by linearly dependent over an interval and linearly independent? Linearly dependent over an interval I, given f1 up to fn are linearly independent over interval I if and only if there exist constants ci, mark it, not all 0, such that summation ci fi is equal to 0 for all x belonging to I. Example to be considered: take x and 2x are linearly independent on an interval 0, 1 closed, because 2x इसके साथ कांस्टेंट 1 है, -1 है, प्लस 2 x के साथ कांस्टेंट है is equal to 0, where constant are not all 0. Now, for the definition of linearly independent over an interval I, we say these functions f1 up to fn are linearly independent over I if and only if there exist constants ci such that summation ci fi is equal to 0 for all x belonging to interval I, then ci is equal to 0 for all I. मतलब सारे जो भी arbitrary constants थे that should be 0. For the example of it, x and x cube on 0, 1 are linearly independent because we cannot find non-zero constants such that their summation would be 0. It need to be 0 and 0. Now we arrive at some of the conclusions, that is, FIs are linearly dependent, then at least one of them is linear combination of others. Second, Fi are linearly independent, then none of the function is linear combination of other functions. Third, Fi are linearly dependent over an interval I, then it implies that Fi are linearly dependent at each point in the interval. It is an important point. In fact, fourth is also a very important point. If fi are linearly independent on an interval I, it need not imply that fi is linearly independent at each point in the interval. For example, if we take f1 of t equal to e raised to power t and t e raised to power t and f2 t as 1 and t, they are linearly dependent at each point in 0, 1, but they are linearly independent over the interval 0, 1. Now some of the exercises show the following functions are linearly dependent: sine square x, cos square x, and 1. We know the identity. So by the help of it, sine square x plus 1 cos square x plus minus 1 into 1 is equal to 0. Second, e raised to power x, e raised to power minus x, cos hx. It is a homework for you. Use the definition of cos hx. Third, x e raised to power x e raised to power x, and 2 minus 3x raised to power ex. It is also simple. Now let's talk about existence and uniqueness theorem. Now let pi and q be continuous functions of x over an open interval I, and if x naught belongs to I, be a real number, and y naught, y1 up to yn minus 1 are arbitrary real numbers, then there exists a unique function phi of x in some neighborhood of x naught, which is solution of the differential equation y raised to power n plus p1 y n minus 1th derivative plus p2 y n minus 2 derivative plus so on e raised to n y equal to q, such that phi of x naught is equal to y naught, phi dash of x naught is equal to y1, so on, phi n minus 1 x naught is equal to y n minus 1. Basically, these are the initial conditions given to us. When initial conditions are given, we get a unique solution. इस थ्योरम से हमें यही पता लग रहा है. एंड ये जो फॉर्म है हमारे पास, ये जनरल लीनियर डिफरेंशियल इक्वेशन ऑफ ऑर्डर n है. अभी हम देखते हैं वो क्या होता है. बेसिकली जनरल लीनियर differential equation of order n, which is p naught y raised to power n plus p1 y raised to n minus 1 plus so on up to pn y equal to q, where pi's and q are functions of x defined on an interval I, which in turn implies if Q is equal to 0, then we say homogeneous linear differential equation. If Q is not equal to 0, we say non-homogeneous linear differential equation. Now, general linear differential equation of order 2, second order, d square y dx square is of the form f x y dy over dx, where x is an independent variable, y is an dependent variable, and इसको linear हम कब कहेंगे? If f x y dy over dx is equal to of the form gx minus p of x into dy over dx minus qx into y. That is, if f is linear in y and y dash, where g, p and q are functions of x only, the independent variable. Hence, y double dash plus p y dash plus q y equal to g is the general linear differential equation of second order. इनको primes भी बोलते हैं. Basically double differentiation with respect to x of y. It can also be written in the form p is to power x y double dash plus q y dash plus r y gx, such that p of x is not equal to 0. If g of x or small g of x is equal to 0, then we say homogeneous, and if not equal to 0, then we say non-homogeneous.